In this problem, we have the series from n equals 1 to infinity of n squared plus n minus 1 divided by n to the fourth plus 17n squared minus 12. So we're going to use the limit comparison test to see if this series converges or diverges. Okay, so the limit comparison test says that suppose you have a sub n greater than or equal to 0, and you choose a b sub n greater than or equal to 0. If you can prove that the limit of a sub n divided by b sub n is equal to L, and L has to be between 0 and infinity, then they either both converge or diverge together. Okay, so we will be picking our b sub n. The a sub n is going to be this. Okay, if the limit is equal to 0 and b sub n converges, then so does a sub n. And if the limit is equal to infinity and b sub n, diverges, then a sub n also diverges. Okay, so we've got the series here. I've chosen our a sub n. What we want to do is choose a b sub n that's kind of similar to the problem that we have, but that we know for sure converges. So I'm going to just choose the biggest power on top and bottom. So I'll choose n squared on top and n to the fourth on bottom, and I'll leave the rest of the stuff off. And of course that becomes 1 over n squared. Okay, so my b sub n is 1 over n squared. Now what I want to do is take the limit as n approaches infinity of a sub n over b sub n, which is n squared plus n minus 1 divided by n to the fourth plus 17n squared minus 12, and then divided by 1 over n squared. Okay, now recall that we have a fraction within a fraction. That's called a complex fraction. So what I can do here is bring that fraction up top and flip it. Okay, so I'm going to just put that right there, and I'm going to say that's times n squared over 1. Okay, so I'll cross out that denominator, and this is how I'm going to write it. Okay, and now I can multiply straight through. Okay, so that becomes the limit as n approaches infinity of, and let's multiply it straight through, so the top becomes n to the fourth plus n to the third minus n squared. So I'm distributing the n squared to each one of these terms on top. The denominator stays the same, n to the fourth plus 17n squared minus 12. Okay, and now what I'm going to do is divide by the highest power on both the top and the bottom. So they both have an n to the fourth. Okay, so I'm going to divide by, and that's each term, I'm going to divide by n to the fourth. Okay, so let's write that here. So divide by n to the fourth, divide by n to the fourth. Each one of these terms is going to get divided by n to the fourth. Okay, and we will reduce in our next step. Okay. All right, so that's equal to the limit as n approaches infinity. Okay, the first term, n to the fourth over n to the fourth, is 1. And then we get n to the third over n to the fourth, which is 1 over n. And then this one becomes minus 1 over n squared. And on the bottom, we get 1 plus 17 over n squared minus 12 over n to the fourth. Okay, the reason we did that is because it helps us take our limit. Okay, so as we let n approach infinity, all these fractions that have an n on bottom and just a number on top, no variable on top. Notice that none of the fractions have an n on top in the numerator. They only have n's in the bottom. So the denominators is going off to infinity on all these, whereas the numerator is just staying where it is. So that means every one of these terms right here are going to go to 0. Okay, so that leaves, once we take the limit, all those terms go to 0, so it leaves 1 over 1, which is equal to 1. So what that proves is that when we took the limit of a sub n over b sub n, we got an answer of 1. So L is equal to 1. Okay, so recall that it says if we take the limit and we can prove that it's equal to L, and L is some number between 0 and infinity, then they converge and diverge together. So if we can now show that b sub n converges, then that proves that a sub n converges as well. And it's very easy to show that b sub n converges. If we take the limit of b sub n, take the limit as n approaches infinity of b sub n, which is the limit as n approaches infinity of 1 over n squared. Well, as n gets infinitely large, then this fraction gets infinitely small, so that's 0. So that converges. So, since L equals 1, and since b sub n converges, then a sub n converges as well.